if I just take the query out of the stored procedure, well, all of these red lines are here for a very good reason. I haven't created these temp tables. The temp tables are created as I run the procedure, and they exist within the scope of that stored procedure. So I can't just run this code right here because SQL Server's like, what page numbers _1? So what I'm going to do is I do want to be able to play around with this. And my thought in looking at this query, let's just look at this query for a minute. So the logic behind the query, what we want to do is we want to return a list of all the page numbers and then just whether or not the page is present in the initial index, after we run the specified modification, after we run a reorganize, and so on. And to do this, since we've created 5 different temp tables, what this original query is doing full outer joins, saying I want rows on from both sides, but if the page IDs match, join them up. But it doesn't have to be like to include in the data set like the page number. It doesn't have to be in page number 2. When we're joining in page numbers 5, for example, the page numbers in that table, even if they're not in any of the other tables, we want them in the data set. But if they are already present, we want them to appear on the same line. Okay, well so that's what we want. Do we need to have 5 separate temp tables? When I first wrote this procedure, as I was writing it, I had some code and that's just what I did. But that wasn't maybe the best decision. Why should they necessarily be in 5 different temp tables? I could keep them all in one table and then have a column that indicates which test run are you from. I'm running 5 different test runs, so I could just have a column indicating what test run they are from, and then process the information with one temp table. So I want to test that out and play with it. So just for rerunability, what I'm going to do is I'm going to take the code out of the stored procedure and I'm going to swap in literal values for the parameters. Now, this can be kind of time consuming and sometimes it's a little more trouble than it's worth. I've done this multiple ways, but in this case, the stored procedure is simple enough. I've only got 5 different parameters and I'm not calling any sub procedures that I need to change or anything like that. So in this case, I'm just going to say, okay, I'm going to copy out the code from this procedure and I'm just going to work on it against my test system. I'm going to comment out the create part of this and I'm going to go through the code and provide literal values for all of these parameters. Another approach is to use local variables instead of parameters, but local variables can behave quite differently than parameters. So for me, for simplicity, sometimes it's worth just going ahead and using literal values. I do have to be careful though, because in this modified code, if I copy this and paste it back in, I have to make sure I don't accidentally leave those literal values in place. So I have to be somewhat cautious. So just for rerunability, I have a drop statement here in case I have created any of these temp tables in my session. We are going to be just going with one temp table named page numbers. But if I'm playing around with this and maybe creating other ones, that's why those are in the drop statement as well. All right, well, let's get going here. We're going to go ahead and manually run the first statements in here, where we create index mate test. Hey, that was fast, right? That was super fast. And then we add some rows. I've used the literal value, 100,000 here, instead of the former parameter for number of rows. That finishes in 2 seconds, right? That's not taking super long. And obviously, this is one way I can figure out what the slowest part of the procedure is. I just have other options if I want to figure it out based on the dynamic management views or work query store. I'm going to create the index with the specified fill factor, and I have put in the literal value instead of the fill factor there. So and I need to run these two together where I declare the SQL variable there and then run it with sp execute SQL. And then I'm going to go ahead and create the table page numbers and insert data into it. Now, notice I'm not creating page numbers _1. I'm just creating a table named a temp table named page numbers, and I'm putting in a column that says test ID. That column is new. And for my first test run here, I'm saying, hey, this is number 1, right? So instead of page numbers _1, my data itself has on the rows, which test run are you from? Now, these 2 columns here, these 2 columns have carried over from the past version of the procedure. If we read through the code at the end, I am collecting this information, but I don't actually use it. We do not actually need these columns. We do not even need to insert the data. So in this run, I actually have them in the table and they allow nulls, but notice that I'm not even putting anything in them, and I may as well just remove them from the table. This is something that happens in a lot of production code too. In an early version of something, we need more data than we do in a later version, but we forget to clean it out. The more data I populate in my temp tables, the slower everything's going to be. So I shouldn't collect things that I don't actually end up using, like some sort of data hoarder. All right, so now we create the table and insert the data for test run number 1. And although my screen had some latency there, that actually finished in less than 1 second. I then run that delete. And I have put in a literal value for the number of times to run. Now, I'm running into a problem here because I'm just running this piece by piece. I have declared the variable for my iterations. I've declared that higher up in the procedure. This is part of why just running things bit by bit is tricky and troublesome. So what I'm going to do here is I'm going to back out. I'm going to go back up. And I'm going to go ahead and run that rerunability code. It's using drop if exists. The only temp table that exists there is page numbers. And now I'm actually going to highlight all of the code I've modified and run it up to the statement run to here. And what this is doing is running each test. It's doing the modification, the reorg, the offline rebuild, and the online rebuild, and inserting data. The changes this time, it's putting everything into page numbers, and each test has an integer saying what the test is. So let's run that all as a group so that I have the luxury of using variables declared in line there. That all completed in 5 seconds. And now we get to the query that we're trying to tune. Now I will say that because local variables can behave different than parameters, and I do have some local variables in here, right? I have some variables that I pulled out from the procedure. When I'm running code outside of the context of a stored procedure, I don't take too much credence to how it performs because things like parameter sniffing can come into play inside the, if I put it back into a stored procedure. So I'm going to take this 5-second execution with a grain of salt. But here is the query we actually want to tune. This is the original version of the query, just in case I want to reference it. And thinking through what I want to display. What I want to display is I want these columns. I want the column page number and then a column for the initial index with a list of what pages show in there. And now I've got everything into a single table. So there's a couple different ways I could write this, given that I now have a single temp table instead of 5. I mean, I'm not going to need all these full outer joins anymore. One way I could do this is using a pivot. I can use a pivot to say, here is my source data set. Whenever we're using a pivot, we don't get to specify the exact group by columns. One of the best practices because of that is to select the exact columns we need as a pivot source table. Just in case other columns get added to whatever table we're referencing later. Yes, this is a temp table, but someone could add those extra columns back in there, right? That I'm saying, hey, we don't need those. So it's a best practice to have a derived table in your query that says, okay, for my pivot, this is exactly what I need. We just need the test ID column saying, at what point did this happen, right? Which of these things did it happen 1 to 5? 1 is initial index, 2 is after modification, and so on. And then I need the page number. And I'm just going ahead and aliasing. I collected that with the name from the DMV, so I'm aliasing that as page number. I am then going to pivot the data. For test IDs in 1, 2, 3, 4, and 5, I want to see the max test ID. Now, why am I doing a max? A pivot requires that I use an aggregate function, and max is going to be somewhat harmless to my query. I'm then going to look at, okay, when I'm returning this, I'm supposed to return this in the format of page exists. My original query actually used, it didn't just return 1 or the page count. It said page exists where the page existed, or it said null. So I have a case statement that is looking at the output of the pivot and saying if it's greater than 0, then the page exists. The max is going to be 1 if it's present. Otherwise, nothing, end as my case statement. So let's go ahead, and we're ordering by the page number. That is the way that our original query did too, is it ordered things by page number. So I've rewritten this way, and okay, well that took not very long to return 20,893 rows. That took less than a second. And I can see at the top here, these pages are just after the offline rebuild, right? Scrolling through, I have different information for different pages. Okay, well, that's kind of cool. Let's look at the execution plan. Turn on my actual plans, look at how this is run, and okay, that's much simpler. We're doing a table scan of page numbers. It's then working on that pivot. I've got that max aggregate in the pivot. We're then sorting it and doing a compute scaler for all those case statements that we've got. And we're saying, I want you to return this in the order of the page number. So that sort has a reason behind it. I have said I want the output to be sorted in a specific order. All right, well, there are other ways to rewrite this too, and I actually like this one better because I think it's quite simpler. Another way to do it is to use GroupBy in case. So I've got a single table named page numbers. Okay, I want a unique list of page numbers. Let's group by the page number, which in this case has the formal name of allocated page ID. For my first column, I'm just going to return the page number and call it page number. For my second column, I'm going to say for this page ID, if the test ID is 1, then put the text page exists. Otherwise, put the characters nothing, end. And then I'm going to take the max of that. Why take the max of that? Well, I'm doing GroupBy. So since I'm doing GroupBy, I need to throw an aggregate in there. But guess what? If I want the maximum of page exists and nothing, that's going to work out just fine because page exists, if it shows up there, is going to be the max. It is greater than nothing. I'm doing this for each test ID to have it show up in that column. And just like before, I'm ordering by page number. So let's go ahead and run this one by itself. That finishes in 0 seconds as well, less than 1 second. And that timing even was with having the execution plans on. I've got a slightly different plan this time. I am still scanning page numbers, that makes sense. But then I don't have the hash match aggregate right away. I'm doing a compute scaler. Then I've got the hash match aggregate, and then I've got the sort. So if I run both of these guys, let's see, this one returned 20,893 rows. And when I run the entire procedure, one of the funny things or tricky things about this procedure is when run with the same parameters, it does not always return the same number of rows. And that's natural. But that makes tuning it really fun. But right now, since I already populated my temp table and I'm just running with different ways to slice and dice it, right now when I'm testing different ways to query it, that does return the same number of rows. So 20,000, both queries return 20,893 rows, which is really quite useful. I can also do other things if I want to compare them. Now that I know they return the same number of rows, I could say except. I could run the first query and then say except the second query. Now, one of the rules here is I can only have one order by. So I commented out the order by on the first query, But now I can see that the second query is a subset of my first query. I got no rows back. I know they returned the same amount of rows. So except can be quite useful. And looking at my execution plan, hey, it's running one of them, doing a right anti-semi-join and running the second one there. So since I've written this a couple different ways, I'm not guaranteed that they return the exact same results as my original query, but at least my two ways of writing this do return the same results as each other. So there's a small amount of comfort in there as well.